Good morning, everyone. Welcome to the third week of our course. I will go through the list of things you have put here as a review from last week. But at the same time, I have two other questions open. I cannot put them all at the same time on the screen, but you can answer those while I'm going through these. So what did we do last week? Well, we have had 2 lectures already. This is the third one. Time goes fast. Last week we learned how to commit, push, and add photo. So we learned a bit more about working with Jupyter Notebook. So you work with the Markdown, you added a photo, and at the same time we learned about GitHub. So you have learned to commit, push. You learned many concepts about GitHub, the keywords that you need to know about, and main concepts, but also you practiced how to work with repositories, branches, commit, pull, push. And with Python specifically, we worked with lists. So we learned how lists work, how to define them, how to manipulate them in different ways. And today we are going to continue working with that, with lists. And you will see you can do even more with lists in Python. So that was pretty much what we did last week. So about Git specifically, some of you find it a little bit confusing. You need more practice, but it is a bit confusing at first, but you get used to it and then you will just use it for your work. You will see that it is very beneficial to your work. So give it a few more weeks. For some of you it's going well, which is nice to hear. But you will get used to it. But compared to most years we have taught this course, you have done a lot better. Like there have been less questions at least, and things have been more clear, so you're doing very well. Then the other question is about pair programming. So this is something we have, but there are very mixed opinions about this. Some of you enjoy it, like working with someone else. Some people don't like it. So first few weeks there's always a bit of struggle how to make it work for everyone, but it seems to be going well now, and all of you have found your pairs. And if you have any issues contacting with your pair, just let us know on Discord and we will help you with that. But I think everything should be fine now. I believe this is about auto-grading. It's fun and works fine too. That's great to hear. I just posted something on Discord half an hour ago about auto-grading. For those of you who are attending the lecture, you have heard this before, but for some it might be, I felt like there's a need for a reminder. Well, this is the first time we are using this auto-grading system. We have had before we have had other ways of auto-grading exercises. So it's good to hear that it's going well, but I wouldn't be surprised if there are like a small bugs here and there. So one thing to remember is that even if you get auto-graded, assistants will go through each exercise. So if the auto-grader has made a mistake and you have lost a point and you think it's not fair, you don't need to worry about it. You don't need to even write us. Because we go through exercises and we will see if the auto-grader has made a mistake, we correct that. So if there is something, don't worry, but it would be good if you can report it to us. I've been getting some emails from some of you, which is nice, like feedback about how it works. But we have made a channel on Discord about this. It would be nice if everything is in one place, because later, after this course, probably we will see it and try to improve the auto-grading. So if all the comments are in the same place, it would be easier for us. But it would be great if you can share feedback. So if something is going bad or your experience is somehow not good, let us know and we try to improve it already this semester, this period, or if not, for next years. So that was about auto-grading. About submissions, we hope that most of you, if not all, would submit in time, because it's a big class. You don't see everyone here, but we have around 80 students, so it's quite big. And we have a tighter schedule. We have a lot to grade, and there are so many topics every week. So if you're late with submission, we cannot promise that we can grade you. So try to submit your assignments latest by Monday. And if there is some issue, let us know in advance. Okay, if there are no further questions, let's start with the topics for today. While I give you an overview of the topic we are covering today, you can already open Nope and pull the latest changes. I've already done it on my end. So if you haven't done it yet, it's a good time to do it now. So what are we going to talk about today? Actually, from this week on, like, things get even more interesting. If you were lacking motivation, why you would need Python or programming in general for your work, this is one of the weeks that some of you would realize that, okay, this can be quite useful. So, as I said already in the first lecture, for many of us who are not computer scientists, one of the main motivations why we want to use programming for doing what we do in our field is to automate processes. We have like large files, we have different data sets, and we want to analyze them in an efficient way. And in software, it may not be always efficient if you're repeating something. And this is one of the gateways. The topic we are covering today is one of the gateways to automation in programming. So we are going to talk about for loops. So you will learn how to create a loop, as you can guess from the term. If you have worked with other programming languages, probably you know what I'm talking about. But if not, probably you can guess from the term. So you create a loop, so you can repeat a task in an automated way. So that's very useful for analysis of data, different kinds of data. Another thing that we are going to learn about today is conditional statements. And that's also a very core concept in every programming language. So you want to have depending on the circumstances, and the circumstances can be the variables, the inputs, whatever you have in your environment. Depending on the situation, you want to control the behavior of the code. So if something happens, the code should run a certain piece of code. So today we learn how to do that, how to control the behavior of your script so that it acts in a certain way depending on certain conditions that we define for the code, in the code. So yeah, so we will work with these topics, and as usual we will have the good coding practices, writing readable code, so we will get to that toward the end of the session today. So yeah, let's get it started. We will start with for loops. So I guess you have already pulled the materials for this week. Let's open for loops. Okay, so last week we started talking about lists, and that gave you an insight into how we can handle large data sets. We are going to work with like even larger data sets, seeing how we can efficiently use different libraries to analyze real data, already starting from next week or the week after. But we already got an insight into how we can analyze a list. So a list was a collection of values, and these values can be just, last week we saw few items in a list, but it can be thousands, more, millions, as much as your computer can handle. When you're dealing with a small list like the one you're seeing on the screen, similar to what we have done last week, it's okay to work with the values individually. You just put the index value, you update the value, you delete it. But imagine, lists are rarely this short. The whole idea of having a list is that you have a lot of values. So you need to have a more efficient way of iterating over the list. So we have the concept of for loops. It's not only for lists, but it's particularly useful when working with lists. So let's start with an example, a bad example of doing things, and then we will see how we can improve it or do it better using for loop. So yeah, so let's consider an example using the list below. So we have 4 items, 4 European capitals in this list. So the list name is European cities. It is typed in, so let's just run this cell so we can access the list. So you probably remember, if you want to access an item in your list, you can access it easily using the index value. So if I want to access the first item on my list, you remember it starts from 0, So if I just run this, I get Helsinki, which is the first item in my list. And if I want to get the second item, and I'm just going to copy and paste this, so it takes less time. I'm going to get Paris. And you can continue doing this for each of them. So you have a list, you want to print all the values. So using what we have learned last week, this is the way to go. You just access each of the list items one by one using the index value and you get the item. But this is, as I said, is not a good example. It works for 4 items, but if you have 100 of them, then it takes forever. So that's why we want to automate this process. So now let's, as I said, this is not a good idea, so we will see how to do it better. Let's continue with a new list. So European cities, and this time we have 3 other cities, Riga, Rome, and Athens. So let's run this line of code. And again, I'm going to access the items in my list. One by one. And then I try to access the third item, or using index 3, and you see you get an error. And we learned this, that okay, we have only 3 items here. So if you go with index 3, it's looking for a 4th item. Well, this is not new. We saw this last week. But this is another reason why you want to automate the process. So in the automated process, the code will know that you have only n number of items in your list. So you won't run into this kind of error. So this is another reason why writing the code or accessing list items manually, not only it's like laborsome, you have to type a lot, but also you can run into these issues because you can easily forget how many items you have in your list. So that was a bit of motivation behind what we are going to do next, and that's writing a for loop. So I will start the process by defining a new list of European cities, different cities this time, just to keep things a bit more interesting. So now I'm going to write the for loop. So it's a new concept in Python, so we will see how it works, but also we have to learn the syntax. So in Python programming, this is the way to write a for loop. So you start with for, and you can see the word immediately gets, like the color changes. So depending on the environment, here it looks green. So Python is recognizing this as a keyword. So this is another example of a word that you cannot use for naming your variable. For is a reserved for, so it's for creating for loops. The next thing you do is to define a variable within the loop. And I will tell you what this means. So for city, so I'm going to read the list one by one, and I place the value in city, so I can access it. And then in is another keyword here. So for a variable in a list. So what is the name of our list? It's European cities. Then you do something. So it goes through the list one by one, and it conducts something, depending on what you want to do. So I want to just print the item to keep it very simple in the first example. So I will go through the items in the list one by one and print their name. So one thing you notice here is the indentation. So it makes a space in the code. And probably already saw this last week in your exercise. So this is Python's way of handling code blocks. So if you have a for loop, it's a block of code that is a specifically for loop. So Python uses this indentation. So this is spaces to know that, okay, everything that is under for loop within the same level. So the level matters. So if you add something here, if it is in the same level, it's considered to be inside that for loop. But if you mess with the size of this, or if it's not exactly aligned, then it's going to get messy. So Python wouldn't like that. So this is Python's way of handling blocks of things. The other programming languages, we have different ways. It might be with different shapes of brackets. So I guess in C language, you have these curly brackets. So this Python, so this is not just to make my code look nice. This is, Python needs that. And this can be, there are good coding practices about this. We are going to talk about this later. But doesn't matter how many characters, how many spaces you have there. Well, here Jupyter is doing it automatically. So I pressed enter, it put it there for me. It doesn't matter how many spaces I have here, as long as it's consistent throughout the block. But we are going to practice this a lot, so you will get used to it. So let's run this code, and you see. So without typing one by one, European cities, index 0, index 1, index 2, I just wrote a for loop. It went through the items and printed them out. Here we have only 4 items, but even if you had like 1 million items here, you would have gotten it to the screen rather efficiently. So this is how we write a for loop, and we are going to practice this with this a lot today. So not only this is shorter, but also it's more flexible to work with. So try printing out a different list of cities. Now we have a longer list, some cities in the United States, and see if it still works. So I'm going to define the list. It's already typed in. What I'm going to add here is, well, let's just define this list. And then in the next code block, I'm going to write a for loop. So try not to look at the screen and practice this yourself. So I want to go to the cities, in, and then I'm going to put the name of the list that I'm going to iterate through. And then you can decide what you want to do in each iteration. So again, a simple example, I'm going to print out the value, the name of the city in each of the iterations. So this is an example of how we can do the same thing with a longer list. So you can already see that this is the structure of a for loop in Python language. So it always starts with for. So Python knows that you are starting a for loop. Then you have a variable. So this can be anything. So it's just the same thing as we learned in the first week. So you're naming a variable. So it goes through collection. This collection can be anything. In our case, it's a list. Each value is read and is stored in variable. Then this is accessible to you. So you can print that variable, you can do some mathematical calculations on it, but it's overwritten in each loop. So next time you go to the second item, so in the first round, the value is stored in city is Detroit. In second loop, it's Chicago, and so on. So it's overwritten every time. Yeah, and of course, remember to put this columns as well. So that's also a part of this for loop. So for variable in the collection, which can be a list or something else, then the colon, and then the code of block where you do something in that loop, and it's going to repeat every time. Okay, so probably you already got an idea why we need for loops for. Yeah, so there's an image that is not loading here, so I show it from the course's website. So an example from your daily loop. So a lot of things that we do on a daily basis are repetitive. So you wake up around the same time every morning. Let's say this cat wakes up every morning at 7 a.m. Then takes some extra nap, then it starts looking for food, and then, yeah. So there are a number of things that we repeat, like talking about ourselves. You wake up at a certain time, you have your coffee, you have breakfast, you go to work or to school, and then this repeats all the time. So in programming, very often we do the same thing. So you're repeating the same calculation for the same data or similar kind of data over and over, or for many items in your list. So for loops are made to make your life easy by just automating these repetitive processes. Yeah, so you can think of course, it's an everyday example, doesn't make sense, but to just give an idea, you can think of those different activities that you do, for example, making coffee, as a function. So you perform that, your life is essentially a loop, and in this loop you do a number of functions, carry out certain tasks. So in the code it's the same. You iterate through your collection and you perform a task. You calculate something, you print something, I don't know, you can do many things. So this is the general idea behind for loops. So let's look a bit more closely at loop variables. So note that the variable you define in for loop, like the city that we used previously, is just a normal variable, the same thing as we learned last week, with the difference that it's running every time, so the value is overwritten. So this value still exists after the loop has been run. Let's loop over a list of weather conditions and print them to the screen. So that's already typed in. So we have different weather conditions stored in a list called weather underscore conditions. And now I'm going to write a loop. So give it a name, give a name to the variable. I'm going to call it weather, but you can call it anything you want. Then you have to provide the name of the list. I'm just going to copy the name so I don't have to type it. Remember to put the colon. Python recognizes that this is a for loop and takes care of the indentation, like Jupyter takes care of that, not Python. And weather. So again, I'm going to iterate through these and print the value. So you can see the items in our list. So now I want to show you what happens to that weather variable that we defined. So I'm going to write an F string that we learned about last week. So after the loop, weather is, so I'm going to include the value for the weather. So I want to see when the loop ends, what happens to that variable. So you can see it's pellets, ice pellets. So what happens, as I said, in each loop, this is overwritten, but once the loop ends, the value that stays in the variable is the last value in your collection. So the last item in the list was ice pellets. So when the list ends, that's the value. So just remember the very last list, the last item in your collection will remain as the value of the variable that you use here. Is it all clear so far? Okay, nice. So for loops using range function. So one of the motivations that one of the things I showed you at the beginning today as a motivation for using automation when it comes to going through values in your collection was that you don't run into errors such as the index range. So if you automate the process, then you don't have the problem of accessing a variable or an item that does not exist. And for that, in Python, there's a very useful function called range that we will use in different ways. So let's consider an example where we use for loop with the value as the loop variable and range. And for range, we are going to use input 5. Let's see what happens. So I write a new for loop. My variable is named value. And instead of looping over a list, I'm going to just use the function range. And I'm going to provide an input for that. You can try it with different numbers. Let's run this and see what we get as the output, and then we will talk about what this range function actually does. So I want to print the variable in each iteration. So what this range function does is creates a list, essentially a list of integers from 0. So if you put range 5, it's going to create values from 0 to 4. And this is very useful if you want to, for example, access the index values in your list. So you can use range function to access those. And we will see more examples of this so you can see in practice what that means. So remember, the value that you provide as input to your range function tells you what range of outputs you want. So if you put 5, you're going to get 0 to 4. And there are ways of changing that, and we will see that later on. But by default, if you just provide an integer here, it's going to give you integers from 0 to n minus 1. So as a general rule, of course, you can Google. If you want to learn about range function, it can do different things. You can provide different parameters. You can always Google, check the Python documentations. But also, if you use help, range, this can be any function in Python, you're going to get, it can be any function or any class or any item in Python, you're going to get some information that is built in Python. So help, name of function, it gives you some information about the function. So you get a bit of documentation, but of course there are a lot of web pages out there, and you can see how, you can learn more about how to change the behavior of different functions. Okay, so now take a moment to read this documentation to see if you figure out its behavior. And then once you have read it, try to do this question 2.7. So the program below will print numbers to the screen using range function. Using the documentation that is produced when you use the help, what values would you replace instead of those 3 dots to get the output here? So what would you put here to get this output? And try to get this here. Then we will do it together. And once you're done, add your answer here to see if you get it right. Okay, so the poll is open, yeah. The answers are coming in. Anyone else? Okay, so let's do it together. This is actually the correct answer, but let's see why. So I want to provide a value here so that it would produce this kind of output for me. And this is how I would do it. So of course I'm writing a for loop that will go through the range function And you can provide any variable name. I keep it simple. I just use I as my variable name. Okay, so here you have to provide the output, as you might have understood from the description here. In the range function, if you just put an integer like we did last time, if you just put 5, by default it's going to go with integers starting 0 to n minus 1. But if you can also control the behavior, so where does it start from, where does it end, and what are the steps? So it doesn't have to be like one by one. So this is how you do it. So start, so stop, and then optionally you can put a step, but it doesn't have to be there. It's optional, so if you don't provide anything, it's just going to go one by one by default. So if I want to get the 2 as my first value, so of course the range is starting from 2. And I want the last value to be 8, so the output should be 9. Remember that it doesn't, if you put 5, it's going to print 0 to 4. So I put 9, so I get 8 as output. And then you can see the gap between the interval between these values is 3. So the step is 3. 2 plus 3 is 5, 5 plus 3 is 8. So as this step, I provide the value 3. So this is how we got 2, 9, 3. So it's from 2 to 9 with the steps of 3 at a time. So this should give us the output that we wanted. So let's just print it to make sure. And I get 2, 5, 8. So this is how it works. Very often when we are using this, we want to use the range to iterate over index values. So we might just go with the default to get from 0 to n or n minus 1. But if there is a situation where you need to change the steps or stop point, then you can easily do that with a range function. So now we want to loop over lists using the index value. So so far we have just looped over the index one by one without specifically accessing them using the index value. And sometimes you may need to use the index value because, as we saw last week, if you want to delete an item, you need to remove it using the index value. If you want to access a specific item, like item 4, then you need the index value. But if you want to modify the value, again, you need index. So for doing things we did last week, you need to have access to the index value, so not just blindly iterating over all of them. So let's define a new list, this time some African cities. And now I'm going to write a for loop in a different way. So for I, that's the name of my variable, and I'm going to use the range function. So remember that you can put any variable here, so any value, any integer. So I want to go through my list. So what should I use as the input? What is my index value? Well, I can start counting. I know that, okay, the index value is like how many items do I have? 1, 2, 3, 4, 5, 6. So the biggest index value is 5. But how do I automate it? We learned a function for that last week. How do we get the length of the... So we learned how to get the length of the list using a function called len. So now we can use this to automatically read the number of lists. So imagine, again, that you're automating this. It's not always such a small list. So you just want your code to take care of the length of the list. You don't want to count it manually. So I just put len, and if I change the input list, it's going to still work because I've automated the process. So here I'm going to put the name of my list, which is African cities. So remember, instead of len, I could have just put the length manually, but like I repeated a few times, you want to automate the process. So I put len, so if I update this list to European cities, American cities, I don't have to change anything in my code except the name of the list. It will work. So that's what we try to do in programming. So I'm going to print the outputs now using an F string to see if everything is working fine. So remember, in fstring, you can access your variables using these curly brackets. So I'm accessing items in my list one by one. So remember that we are iterating through index values from 0 all the way to n-1, which is the biggest index value we have. So and this I is going to get overwritten every time. So it starts with 0, 1, 2, 3, 4. Is at index. And I'm going to also print the value of I, so I know at which index I am in each iteration in the list. Okay, so you see it works super fast. And you get the fstring. So it goes through each of your cities one by one. So Dakar is at index 0 in the list. So it goes, I is updating in each loop, and you get the value for that index. So this is another way of how we can loop over lists using a for loop, but this time with accessing the index. So for example, you can update the value. So in programming, you very often see this I. If they're accessing, in Python, if they're accessing indexes, very often the variable, you can choose anything, but very often I is used because it's short for index. And if you have several for loops, for example, if you have nested loops, it's very common to use letters J and K. If you need all of them, then J and K are also common. But it can be anything, it's just a habit in world of Python. So I already tried to explain why we might want to use index value to loop over a list, but let's see it in practice, why you want to do that, because your code, of course, gets a tiny bit longer here compared to what we did before. So let's see why we might actually need this. So now I'm going to define two other lists. One is cities, some European cities, and then we have countries, and these are corresponding. So the city at index 0 is matching with the country at the index 0. So this is a situation we might have very often in our programming. So there are better ways of doing this that we are not going to use right now. So we just want to see how to use the for loop. For example, there is a function called enumerate that can help, but we are now going to do it a bit more raw way. So let's run these two lines and define our lists. Cities and countries. So as you can see, we have 5 cities and 5 corresponding countries. Let's print out each pair using a single for loop. So this is something we have done a few times already today. So I'm going to start with cities. So for I in range. So we do it the same as last time. Cities. I'm going to print the value, of course, which is cities, and provide the index value. And I'm going to also add a piece of text. So remember, you can also do this as an fstring. Is the capital of So it gets this nice output. So it's iterating, actually, you have only one for loop, but it's iterating through 2 lists at the same time, kind of, because you're not iterating through the lists specifically, you're going through the I values, and you can just provide this I value as the input of your list to get the access. So I'm just making one loop, so this is efficient. Imagine you're working with very large lists. Instead of iterating through each of them, I just wrote one for loop. I get the I value here, I access the cities and the countries, and because the lists were corresponding, I get this text nicely as the output. So Helsinki is the capital of Finland, or Stockholm is the capital of Sweden. So this works nicely. So now you don't need to worry about this, but for loops are one of the things that, like loops in general, are the things that can make your code slow. So you have to use them wisely. So imagine you have a data set of million rows of data. That can easily happen if you have some weather data or, I don't know, many different kinds of data. And you're writing a for loop, and in each iteration, you're not just printing, you're calculating something. So imagine this is going to repeat 1 million times and calculate something. So this is one of those bottlenecks in your code very often. So you want to do your best to make it as efficient as possible. But like I said, we work with a small data set, so we don't have to worry about it yet, but yeah, that's something to think about later on. So as you can see, the index I is used to, in this case, to access each item in the to-do list. So with one for loop, we could access both of the lists. So now let's practice one more thing. And this is the last thing we are doing related to for loops in this part of the lesson. So what output would the following program produce? Try to first think about the loop without running the code. So don't run the code right away. Just think about it, try to read the code and guess what would be the output. You don't have to tell the right answer, but if you guess the output, you can raise your hand. And I won't challenge you further. Okay? Yeah, some answers, yeah. Okay, so we have two lists similar to the city example here, except that we have numbers here. So we have values from 1 to 9, 1, 3, 5, 7, 9, so odd numbers from 1 to 9. And then we have even numbers from 10 to 2, so 10, 4, 6, 8, 2, not in a logical order. So for I in range, so I'm doing the same thing, iterating through my numbers, and this time I'm doing a simple calculation. So I'm adding up the two numbers. So I'm adding this one with this one, at 1 by 1. So you can guess that the output will be 1 plus 10, so 11, 3 plus 4, 7, 5 plus 6, 11, then 7 plus 8, 15, and 9 plus 2, 11. So let's just run this to make sure that I was right. And I was right. So this is, again, very simple. You're just summing up two numbers, but this can be any calculation. So if you're working with real data related to your work here, you can do calculations. So this is how we use for loops. Okay, so now it's a good time maybe to take a short break, 10 minutes of break, and then we will continue with the second part, which is about conditional statements. Yeah, let's be back here at 10 past 10. Let's continue. Now we are going to talk about conditional statements, and I briefly mentioned at the beginning of today's day that, well, almost like in real programming, it's harder to think of a scenario where you don't have this if statements or conditional statements, because that's one of the main ways you control the behavior of your code. So imagine you're calculating something, and depending on what the input is, you want to run a certain kind of calculation. Or if you're iterating through rows of your data. You have a CSV data file, something that we will be working a lot with in a couple of weeks. And you have some missing values in some lines, and you want to skip those. So you have to put a condition telling the computer or tell the program that if a certain value is missing from this line, skip the line. Or if the value is positive, do this. If it's negative, do this. So a lot of these kind of conditions you want to define for your program to control its behavior. So all programming languages have these conditional statements. They might look a bit different in terms of syntax, but the concept exists. So in this section, we will learn how to make choices in our code using conditional statements, if, elif, and else, and soon we will learn what they mean, and Boolean values, true and false. So we have talked about different types of data so far. We have seen integers, we have seen floats. Another data type that we have talked about but not seen is Boolean, so true and false, or binary values. So we will be working with those today. So conditional statements can change the code behavior based on a certain condition that you define. The idea is simple. If a condition is met, then you conduct a certain range of actions, and if it's not met, then you do something else. So this is what you're essentially telling the computer. And you can think of it like many machines that we have at home, like many appliances have these conditional statements built in. So if you think of a washing machine, probably they have programmed it, and there are a lot of if conditions. For example, if it's emptying the water in the washing machine, and if it's empty, if the sensor is telling that there is no more water, just stop the pump. So it's full of these conditions defined. So that's what we're trying to do. We will start with a very simple conditional statement working with temperatures. Let's look at a simple example with temperatures and check if a temperature of 17 degrees Celsius is hot or not. Like we talked on the first week, computer itself is not going to understand that. So if you want to design a program that is going to tell, this is a very useless program, but just as an example, if you want to design a computer program that tells people whether it's cold or hot, you have to define that for computer. And one of the ways to do that is this conditional statements. So yeah, so let's get it started. The temperature is 17, that's the input. Then I'm going to write an if statement. I make a couple of new lines here. So this is how you write your if statement. So it's very intuitive. So if, and then after if, you have to define a condition. So my condition is that if temperature is greater than 25, so similar to for loop, you should have a colon here. So this is telling Python that, okay, I have an if statement here, and this is the block of code. So these are the things that would happen if the condition is met. So note that there is an indentation automatically created for you. Then here you can do anything. So if the condition is met, something will happen. And that something in our case is very simple. We are just going to print out something. So I'm going to print out the value for temperature. Is hot. So let's say if it is over 25 degrees, I'm going to tell the user that, okay, it's hot out there. So very often when we have an if statement, we should also try to handle situations where that condition is not met. So if temperature is 25, it's hot, but what if it's 22? You want to handle that situation as well. And for that, you write another statement called else. So if this, then you do something else, which means that that condition is not met. Then what do you want your program to do? I'm going to print another thing, an f string. In the f string, I'm going to say, I'm going to print out the temperature value. I'm just simply going to say that it's not hot. So if it's not over 25, it means it's less than 25. So I just keep it simple and say it's not hot. So let's just run this and see 17 is not hot. Of course, that's what. So you can try it with a different value. So I'm going to put 26 and run it again. And it says 26 is hot. So if the condition is met, if temperature is greater than 25, then this will happen. This line of code will be run. which says is hot. So when I put the value as 17, like it was first, it's not going to even run this. So if this is not met, this condition is not met, so it's just going to skip everything that is under if. So even if I had a few other things, print this, print that, calculate this, calculate that, so everything under if would be skipped because the condition is not met. And then it would go to else, because else is always, if the if is not valid, then the else will happen. So temperature is not hot. So yeah, so that's the basic logic behind if statements, and they are quite simple and intuitive. So we already tried this part, but let's just copy and paste this code and try it with a different temperature. So this time I'm going to go with 30. You can try it with any value that you want to see if the code works. And it should work. So I get the same output with 30. 30 is hot because it's over 25 that I defined as threshold. Okay, now how about if without else? The combination of if and else is very common, but the else statement is not strictly required. So it's very nice to handle the situation where your condition is not met, but Python doesn't necessarily expect that from you. So Python simply does nothing if a statement is not true. So let's try this now. So I go again with a temperature equals 17. And if temperature is greater than 25, I'm going to print something. F. So I ran the code and nothing happened because I didn't have an else statement. So if condition was not met, 17 is not greater than 25, so just nothing happened. So if this is what you want, you check for something. If it is correct, you do something, and that's it, then you don't need else. But if you want to handle also the situation where your condition is not met, then you need to also have else, but it's not required. So conditional statements always check if the conditional expression, and now we just work with greater than. There are other expressions we can write, and we will see them soon. So conditional statements always check if the conditional expression evaluates as true or false. If true, then the code block under the if is run. If it's not true, then it's not run. It's just skipped. It goes to else if there's an else. So let's look at another example from our daily lives. As it turns out, we will use logic similar to if and else conditional statements daily. So we do a lot of this if and else in our daily lives. So if you want to write it as a program, this is how it would look like. So now I want to decide what I should wear. Imagine you want to make another useless program that will tell you what you should wear depending on weather conditions. So I'm going to write an if statement. I have defined already a variable called weather. So, for example, if it's rainy. And then I'm going to check a few conditions to see if they're met. So if the weather is rainy, and remember that we will see this soon, but when you're doing conditions, you have to have double equal sign if it's a conditional statement. So before, when we were assigning a value, when you're assigning a value, it's 1. So this is a mistake that many people make if they're new to Python. If you're checking a condition, so this is conditional equal. This is equal that is used for assigning a value. So if you just put 1, you will run into issues. So if weather equals rain, then you're going to tell your user to wear a raincoat, which makes sense. Wear a raincoat. But what if it's not rainy? Then you're going to add an else statement in which you will just tell the user that no raincoat is needed. Yeah, so the weather was rainy, so the code is telling you that you need to wear a raincoat because the if condition is correct. So if you just replace this rain with anything else, like sunny, sun, or cloudy, it's not going to, the else condition will be activated. So it will print no raincoat is needed. So you can see, like, this might seem like a useless piece of code now because it's a very simple case, but even this simple thing is very useful. For example, if you have seen, probably have seen these digital thermometers at home, that they tell you if the temperature is comfortable or not. So they have these codes like defined in them. So if indoor temperature is more than 20 and the humidity is this, then it's not comfortable or it is comfortable. So yeah, so this is how the behavior of machines or programs in general are controlled. So similar to for loops, remember that when you have else or if, and you're starting a new block of code in which certain things can happen. So the sign for Python to know that your code is following, your block is starting, is the colon. So remember to put the colons. And when you put the colons, the environment, if it's started in smart enough, like we have now Jupyter Notebook, it will create it will put the gap for you. So you will have the indentation here. So very similar to what we had in for loops. And remember, if you have more than one action happening under your if or else statement, just remain consistent with the indentation. So don't write something here. You will run into indentation error. So note that also in the case of text being compared, uppercase and lowercase is important. So rain in capitals programmatically is not the same as rain in lowercase. So think about that, be careful with that, unless you specifically address it in your code. So if rain in capital or in lowercase, wear a raincoat. So unless you specifically say that both conditions are valid, for computer, rain in capital or any text in capital or uppercase or lowercase are not the same thing. So the condition will not be met. For example, if you have a typo like this, and you can try that yourself now. So how do you handle such situations? So if you're making a code for people, you're sharing it somewhere, and you cannot control people's behavior. So someone comes to your website, puts in the weather condition, and wants to see whether he or she needs to wear a raincoat. And they might type it with rain R up, like capital. So in those cases, remember, was it last week or the week before? It was last week. We practiced with this weather, like variable.lower, variable.upper. So you can control the input before you send it to your program. So if you're reading an input from the user, you can put whatever the input.lower to make sure it's lowercase, and then take it to your if statement. So these are things that you will learn by experience if you are especially writing code for others to use. Okay, so let's try something. We might also need some other rain gear on a rainy day. Think about how you could add another instruction after weather equals rain condition so that the code would tell us to wear a raincoat and wear rain boots. So write this now. Let's take a couple of minutes to do this, and then we do it together. So I start doing the same thing at the same time, but you can continue writing your code. Okay, so like I mentioned briefly before, when you start an if statement, you put the colon sign, then it just starts a new block of code for you. So you can just continue adding as many commands as you want. So you can have multiple prints, like here. So we are printing where a raincoat and where rain puts. So it could be many other things. So you can calculate many different things at the same line. And then we have else. So we just added a new print. So remember that when you are going to else should be in the same level as if. So here. So these should be at the same line. So when you're starting a new line, of course, your environment doesn't know if you're going to write else or continue in the same block. So if you want to write else, just remember to go to the beginning of line so you don't get error. And then you start a new block. So it can be in the same level as this one, so it looks nicer, but it doesn't have to be because it's a new block. But of course it looks nicer if your code is nicely aligned. So I'm going to run this, and of course weather is rain, so it equals the condition is met, and you're going to get both these prints on your screen. So now we have already seen greater sign, we have seen equal sign, but you can, it's mathematics, so you can have different kinds of comparison operators. So we have the equal sign that is used for text, so you can check if a cat equals a dog, and the output is of course false. So the outputs are Boolean, so it's 0 and 1 or false and true. Then we have not equal to, so you put an exclamation mark and then equal sign, so it means not equal to. Again, you can use it for text, for characters. And then we have less than, we have greater than, we have less than or equal to, or greater than or equal to. So same operations we have learned years ago in school. So of course it has to make sense, like greater than, you compare numbers. So you cannot say if a cat is greater than a dog. It has to be numbers that you're comparing. But the output is the same, so you have false, true or false as the output. So Boolean values. So let's see how Boolean values work. So I'm going to define a new condition, temperature greater than 25. So this is my conditional statement. I'm not putting it in an if statement. It doesn't have to be. I'm just defining a condition. So I'm going to just run it. And the screen is showing me false. So temperature is not greater than 25. And it's reading the temperature value from our last time we defined it. It was 17, I guess. Yeah, it's so 17. So it remembers that 17. And when you write a condition like this, it's telling you that it's false. Let's also try weather to see if it's still rainy. And it's true because we haven't changed the value. So what if you store this in a variable? So I'm just storing it in a variable. And I'm testing what is the data type of my variable. So it's going to give you the bool or boolean as the data type. So what you're getting when you're writing a conditional statement is returning a boolean value, which is binary, 0, 1, or true or false, and then that is used. So when you're writing an if statement, it's usually a condition, but that condition, what it checks for is a boolean value, true or false. So it doesn't have to be even explicitly a condition. You will see examples of this later. But that's what it's exactly looking for, a boolean value, true or false. So if it is true, it works. If it is false, it skips it. So yeah, so we already learned how to control the behavior of our code a bit. Now we are adding one extra layer of control to even check for other conditions, and that is elif. So when you're writing if statements, we already saw that you can write if, else. So it's either if, it's correct, it is true, it happens. If not, everything else goes to else. Else is always valid if is not. But elif is like a way of adding an extra condition. So you say if temperature is more than 25, it's hot. If, elif, less than 25, cold. So you can add another condition. So let's see how it works in practice. So now I'm defining my temperature again. So it's -3 this time. Let's run this. And we are going to use it here. So I'm defining a condition now. If temperature is greater than 0, I'm going to say it's above freezing. So let's write this. If is greater than 0, I'm going to print. Let's use an F string. So I'm going to say temperature degrees Celsius is above freezing. So what we have done before, we just checked that, okay, is it freezing or not? You don't have anything in between when you're just writing if and else. But if I want to add another condition, and remember to go to the beginning of line because I'm starting a new block, we can use elif. So it's short for else if. So if the first one was not true, then check for the second condition. So you add another condition here. So I'm going to copy this print so I don't have to type the whole thing. So if temperature degrees Celsius, if this is valid, then this will be printed. Then I'm going to say it's 0 degrees, so I'm going to say it's at the freezing point. It's at the freezing point. And then the value might not be 0. So I have two conditions now. Is it greater than 0? If it is greater than 0, this will happen. If it equals 0, this will happen. But I want to also handle situations where it's just something else. So in this case, so I'm going to write else. I'll just paste this again. Below freezing. So if it's greater than 0, it's above freezing. If it is 0, it is at freezing point, then it's obvious. If it's not either of these, then it's probably minus value. Then it's below freezing. So let's just run this and see what we get as the output. The input was -3, so -3 is essentially activating this last one, else. So it's not greater than 0, it's not 0, so it's this one. -3 degrees Celsius is below freezing point. So now we learned that you can have many elifs. So if, elif, You can have multiple elifs. So that can be done. So you can check for different conditions if you want to give a detailed response or plan a detailed action. So, okay, let's take a couple of minutes and try this question 2.10. Let's assume that yesterday it was 14 degrees Celsius, it is 10 degrees outside today, and tomorrow it will be 13 degrees. The following code compares these temperatures and prints something to the screen based on the comparison. Which of the letters A, B, C, and D would be printed out for this? So before running this code, just look at the code and try to guess what will be the output. And then you can run the code to test if you guessed correctly or not. This is an example of a case where you can have multiple elifs, so different conditions. So you always have one if, but if you want to add more conditions, then you can add multiple elifs. Okay, so let's try to decipher the code together. So we have three temperatures defined, three variables, yesterday, today, and tomorrow. Yesterday we had 14 degrees, today we have 10 degrees, and tomorrow we will have 13 degrees. So in the first line of code, in the first if block, at the beginning of if block, so we have if yesterday is smaller or equal to today, print A. So is that true? Yesterday was 14, today we have 10. So yesterday 14 is not, well, 14 is smaller, it's not as smaller than yesterday, or smaller than 10. So this is not met. If a statement is returning false. So this is not going to happen. Let's see the second one. If today is not equal to tomorrow. And that is true, because today we have 10, tomorrow we have 13, and they're not equal. Then print B. So I know that this will happen. So I will have B printed out. But what about the next one? Elif, yesterday greater than tomorrow. So yesterday is 14, tomorrow is 13. So this is also correct. So I have another elif condition that is valid. And then I have another one, today equals today. So this is also valid. But remember that if you have if, then elif, as soon as a condition is met, the rest are skipped, because you met your condition. So if you put many of these, imagining the document and handling every possible situation, that may not be the case, because if one of these is met, then the rest are just skipped. So let's just try this out. I'm going to copy this piece of code, paste it down here. Yeah. So you can see only B is printed and the rest are ignored. So be careful with that. Just acknowledge that this is how it works, and when you are handling those situations, just keep in mind that this is how it works. Okay. Is it all clear so far? Yeah, good. So now let's continue. Another useful thing that we often use with conditions is combining them. So very often you want to check that a number of things. In the same if statement, you might have multiple conditions. So these are a few examples. So with logics, you can control that. So you can have AND as operator. It only returns true if both comparisons are true. So if you put a statement, and we are going to practice this now, if 2 greater than 1 and 1 smaller than 0. So if both of these are valid, then you would get true. If one of them is not valid, so in this case 1 is not smaller than 0, so you're going to get false. So if you have multiple conditions and you use AND in between them, the output will only be true if all of them are true. Then we have or, another operator. So is the situation this or this? So true if either comparison is true. So if this one is correct or this one, then it's true. So if either of them is true, then the output is true. And then we have not. False if comparison is true and vice versa. So not 2 greater than 1. So 2 is, it is greater than 1, so it basically negates the output. So if it's true, 2 is greater than 1. When you put not, it just reverses the value. So if it's true, it becomes positive. If it's true, it becomes false. If it's false, it becomes true. And there are situations where you might need this. So let's look at one example, so that will hopefully help us understand better why we need this. So with this table in mind, so remember this operator, so if you want to add multiple conditions in one line, then and this is the relationship between them. So let's try something new. So we are defining temperatures again. We have one variable named hot temperature, and it has a value of 35 degrees. We have warm temperature, which has a value of 24, and we have cold temperature, which holds a value of -4. And here the code is typed in, so we don't have to type it. So I have written a condition here. So if hot temperature is greater than warm temperature and cold temperature is greater than warm temperature, then print both parts are true. Else, print at least one part is true. So let's just run this. So you get the else output. And the reason is that you have an AND operator. So for AND to return true, both parts, and it can be even more parts, so it can be 3 conditions, 4 conditions. If you use AND between them, all of them have to be true, so you return output. So this is true. Hot temperature is greater than warm temperature. But cold temperature is not greater than warm temperature, according to these numbers here. So this is false, this is true. With AND, the output is false. So this is going to be skipped, and you get the output from else. That is what is happening. So now we modify the statement above to try it with OR. So I'm going to try this. I would just copy this so I don't have to type. You can do the same. So I'm going to modify it and use OR instead. So I'm going to change the sign. So if hot temperature is smaller than warm temperature, or cold temperature is smaller than warm temperature. And then what I'm going to print out, I will edit this part as well. So I will say at least one test is true. So like I said, if you have OR, if you have many conditions you're testing for, if one of them is true and 10 of them is false, you still get true as the output. So this is the case here. So this first one is like hot temperature is not smaller than warm temperature, so it's false. But this one is correct. Cold is smaller than warm. Because one of them is true, then you get true as the output. So now let's take a couple of minutes and test something else. So in some programming languages, you see these signs. So we have AND like this, or is like this. It can mean different things in different languages, but in Python, it's bitwise operator. And we're going to see that later on. So we will revisit that. But for now, remember, if you're just writing an if condition, you use AND spelled out, so you don't use this AND sign. So it can mean different things in different programming languages. But in Python, so don't use those yet. We will get back to them later. But let's try one thing now. Question 2.11, and let's just spend a couple of minutes trying this. Let's return to our example about making decisions on a rainy day. Imagine that we consider not only the rain, but also the wind speed in meters per second. If it is windy or raining, we will just stay at home. If it's not windy or raining, we can go out and enjoy the day. So let's test this. So we have multiple conditions, so you can see that you are already using multiple conditions. Okay, so I start typing this at the same time. So we have three variables defined. We have the weather, we have the wind speed in meters per second, and then we have comfort limit. So I'm going to start with my if statement. So if weather equals rain, or wind speed greater or equal to comfort limit, so we have two conditions here, and if either of them is happening, then I will just stay home. So either it's windy day or a rainy day, I'm going to stay home. In other conditions, if it's not raining or it's not too windy, then I will go out and enjoy the day. So I'm going to print So it was a rainy day, and it was very windy, so the code is telling us that it's better just to stay home. So if you can, of course, play with these values a bit, if you want to test different conditions, just change the numbers, change the weather condition to see what kind of output you get. Okay, so if statement is very simple. Another useful thing that we want to look at now is combining for loops and conditional statements. These are things that we are going to need a lot when we start working with real data. So this is just warm up. Let's see how that works. So we can combine for loops and conditional statements. Let's iterate over a list of temperatures and check if the temperature is hot or not. So imagine you have stored the values. So far we worked with individual variables. Now we have the temperatures stored in a list. So I'm going to create a loop now with an if condition. So start your loop. So for temperature in, and the name of the list is temperatures. Okay, this is going through each single value in my list. Then I'm going to test something. If the temperature is, I don't know, more than 25, then say it's hot. So this is, you can use both of them at the same time. So inside your for loop, you can write if then I'm going to check if the temperature is greater than 25 or not. If it is greater than 25, I'm going to print something using f-string. I'm going to say temperature is hot. And else, remember to fix the indentation, then I'm going to print something else. The temperature is not hot. So let's run this. So you can see this code, this if statement is tested for each iteration. So this is iteration 1, the first item in your list. It's 0, so it's not greater than 25, so it's saying 0 is not hot. For the second value, you have 28. Again, it goes through this if statement. 28 is greater than 25, so it is hot. So same for the rest of the values. So this is basically automating something. So you have a large list of values. You write this and you automated the task. So imagine if you have a very long list, this would save you a lot of time. But we are going to use this a lot for other things with real data later on. So is this all clear? Okay. If yes, then let's look at the good coding practices before we wrap up. We are more efficient than I thought. So writing readable code. So remember, every week we have these good coding practices, and the main goal is to write a good code that is readable for you and others who might be potentially using your code. So this week's good programming practice focuses on the writing code that is easy to read. During the previous lesson, we have already discussed good practices with variable naming and describing the code with comments. So now we will look at other things. So we'll see how to format the actual Python code to make it more readable. So one thing from here that I hope you paid attention to is the indentation. So you can see we have multiple levels of indentation. So we have a for loop. This is everything under the for loop. This whole thing is under this for loop. Then we have if. This is under if. So it can be like many levels of indentation. You have many blocks within blocks. So this is something you will see a lot. So a few notes about making your code readable. So one thing that is good to keep in mind is that you shouldn't, there is not really a limit how long your line of code can be, but it's not recommended to go super long. So for example, if you're defining a list and you have many items, like US cities, and here you have what? You have 8 cities. So if you just type it in, it becomes one very long line of code. So it is advisable not to make it long. So you can just, so this could have worked. You could have just done this probably. But this is not recommended because it's a bit hard to read, and whoever is looking at your code has to like scroll left and right. So you can just put it in a new line. And Python is fine with that because you know that you're inside this bracket, so it knows that, okay, this is continuing. So it doesn't see it as a new line of code. It just knows that, okay, you are continuing here. So if you have very long blocks, like a list you're defining, then it's just good to break it into lines that it doesn't become super long. Same thing with indentation. So with indentation, as I said, there are different ways of doing it. It can be a space. You can just press tab. So you just need to have a gap. So that's what indentation is. So it doesn't matter which one you use. Just be consistent with that. But what is the standard, and many, like Jupyter Lab enforces it, and many other environments, is 4 spaces. So what you're seeing here is 4 spaces. So this is the standard. But as I said, it's not strictly required. So it could have been 1 space. It could have been 10 space. It can be tab. You can make a space with tab. Just main thing is to remain consistent so you don't get error. And the recommendation is to go with 4 spaces. And Jupyter Notebook takes care of that for you. So you go to new line, it puts the indentation like that. So as I said, you might have different blocks and they do not have to be necessarily aligned. But imagine when you have longer code and they are very misaligned, it's going to look very bad. It's very hard to read, like it just becomes less pleasant to look at. So try to be organized with your indentation so you're aligned, even if it's not strictly required by Python. Another thing to remember is that in Python you can write multiple statements per line. Yeah, another thing to remember is like spaces. Spaces are generally recommended. For example, here I didn't have to have a space here, but it just looks nice and it's recommended. So use the spaces wisely. It makes it more readable, like here, it's more readable. I could have removed all these spaces and not get an error. But just avoid unnecessary spaces. For example, with print, for using functions, you don't need to put in a space here, so it's just not common to do that. So you can also in Python write multiple code. So this is 2 lines of code. You can just put this semicolon and write multiple, but why would you do that? It's not recommended. So it's better to just go to the next line. So if you're writing a different line of code, just go to the new line. So don't get tempted to make your script shorter. Yeah, so you have to try to find a balance between things. And you will get better at it over time. Yeah, so let's see what we have for this week as exercise. Yeah, so we are going to continue working with for loops, if conditions, and you will work with lists. You will practice how to work with different nested if statements, so an if within an if. So this is something we didn't look at, but the logic is the same. So if you have a condition here, if the condition is met, then you check for another condition within it. So you will also practice with this nested if statements. And like last week, we will have auto-grading, so you will get feedback every time you push to the repository. And yeah, that's it. And hopefully, did you still have problem with accepting the exercises? Well, some of you had at the beginning of week, but I guess they might have resolved it. So hopefully it goes smoothly from here on. But yeah, that's it for today. Thanks for showing up and see you next week.